Here we have an initial value problem that involves a differential equation and a condition. So we're going to try to use the approach of separable equations where we are going to isolate variables. On one side, we're going to include the y and its differential, and on the other side, we're going to have only the axis and the its differential. So we can rewrite the given equation as dy over 1 minus y equals to 6x squared dx. So we were able to separate variables, and now we have a differential equation that can be solved using the approach of separable equation. So as we already separated variables, we can integrate on both sides. So we have the integral of dy over 1 minus y. This integral can be solved using u substitution. So we have that we can set up u as 1 minus y. Then du is going to be negative dy. So in this context, dy is negative du. So we have a new integral, which is the integral for negative du over u, and then we can rewrite it as negative integral of du over u, and that produces negative ln of absolute value of u. And then we replace our original variable in this integral, so we have a negative ln of absolute value of 1 minus y. So we have on the left side, we have negative ln of absolute value of 1 minus y equals to, well, the integral on the right is easy to compute. It is 6x a third divided by 3, so it will be 2x a third plus c. So now in trying to solve the initial value problem so that we can obtain the exact value of the constant that we can call for now this constant C1, we can multiply by -1. So we have ln of absolute value of 1 minus y equals to negative 2x to the third minus C1. So it is now the moment to try to isolate the dependent variable, which is y in this case. So we're going to exponentiate both sides. We have e ln of 1 minus y equals to e to negative 2x a third minus c1. And then the exponential on the log cancel each other. We're going to get on the left just the argument, which is 1 minus y equals to, then on the right, we're going to have e to negative 2x a third times e to negative c1. And then we can now proceed to call e to negative c1 equals to c. which is in fact the constant we need to find in order to solve the initial value problem. Recall that it is convenient to find the explicit expression of the solution. Explicit means where y is by itself, is isolated, so y depends entirely on x. So we have an expression of y depending on x. So we can write the solution as 1 minus y in absolute value equals to c e to negative 2x a third. So recall the condition, the given condition in the problem, let's recall it, in order to solve the initial value problem is y at 0 equals to negative 2. So the condition, our condition is y at 0 equals to negative 2. So we replace the condition, but keep in mind that on the left we have an absolute value, and then notice that if we compute 1 minus y at 0, which is 1 minus negative 2, which is actually 3, right? The inside of the absolute value is positive, and then this term for the given condition is going to be positive. So we can get rid of the absolute value and write it as 1 minus y equals to c e to negative 2x a third. And then now y will be isolating y. We're going to obtain 1 minus c e to negative 2x a third. So is this now the moment to compute or find the value of c in order to solve the initial value problem? So we have that y at 0 is negative 2. We have negative 2, 1 minus c e to negative 2 times 0 to the third. So this quantity is equal to 1. So we have negative 2 equals to 1 minus c. So c is going to take the value of 1 plus 2. And then that is 3. So the solution to the initial value problem is going to be y of x, y at x, y depending on x equals to 1 minus 3 e to negative 2 x to the third.